question like 45 factorial over 43 factorial. A little bit not the same compared to the first example, but again it is so simple. By using our general formula, as you can see, this is the same as we start with part of the numerator. The numerator will 45 factorial. 45 factorial is the same as 45 times 44 times 43 factorial. Why are we ending in 43 factorial? That is because in our denominator we have 43 factorial. So this one divide by 43 factorial. Now our work is so simple because now we can simplify the case like 43 goes with the 43. Now what remains in our solution is equal to 45 times 44. So my dear student, by using your scientific calculator, you can compute the product we have here. That is 45 times 44. The answer will be 1980. But again, you can go straight by using your scientific calculator as a function for factorial notation. By using your scientific calculator, you can use the symbol for factorial notation and get the same answer. Okay, again, my dear student, suppose we have another question like we have 2 factorial bracket 4 plus 3 factorial. Even this question is so simple because it's just a matter of operation. Where to start? We can have that just say solution. That is 2 factorial. We can start with the operation which is in the bracket. That is 4 plus 3. Remember, these numbers inside the bracket has no factorial notation. So just add it directly. Like 4 plus 3, here we are going to have, that is 7 factorial. Now you can go straight by applying the general formula for factorial notation as already mentioned earlier. This is the same as saying that is 2 factorial, that is 2 times 1, because the number should descend. And again for 7 factorial, this is the same as 7 times, we have 6 times, that is 5 times 4 times 3 times 2 times 1. Now you can use your scientific calculator again to find the answer. My dear student, I think all of you have the scientific calculator. It is so simple to use. Now you can plug in what we have. You can go direct to the question, or you can find the answer by using the last expression we have. That is, we have 2 factorial times, we have 7 factorial. That is 7 factorial. Now the answer here will be equals to, it is 1, 0, 0. That is 10080. Let me write very clear. That is 180. Now let us proceed with another example. suppose the operation change. Like this time we have 7 factorial minus 5 factorial over 6 factorial minus 4 factorial. Even if the operation change, you can look the question, because remember we have the general formula for factorial notation, but again you can use your scientific calculator and end up with the correct answer. Now suppose we want to show the way of how to do such kind of a question. My dear student, it is very simple. For 7 factorial, this is the same as 7 times 6 times 5 factorial. Why 5 factorial? Because the last number is 5 factorial. It will help us to simplify the expression. So here we just say minus 5 factorial over, for the denominator side, we have 6 factorial minus 4 factorial. So we start with the 6 factorial, which is 6 times 5 times 4 factorial. Why 4 factorial? Because the last number is 4 factorial. So here you minus 4 factorial. Now you can see for the numerator side, we have 5 factorial, and the last one is 5 factorial. It means you can write 5 factorial out of the bracket. My dear student, what will remain here? It will be 7 times 6 minus. Here 5 factorial is out of the bracket, so we are going to remain with 1. For the denominator side, what is common is 4 factorial. So you can write 4 factorial out of the bracket. 4 factorial out of the bracket. My dear student, what will remain here? You can see we are going to have 6 times 5 minus 1. Why 1? Because 4 is out of the bracket. Now, again, you can use factorial notation to simplify 5 factorial over 4 factorial, like that is 5 times 4 factorial. Now, why 4 factorial? Because remember, in our denominator side, we have 4 factorial. So now here we have 5 times 4 factorial, bracket, we have 7 times 6 minus 1, bracket, over, for the denominator side, we are going to remain with the 4 factorial, bracket 6 times 5 minus 1, bracket. Now you are in a position to simplify, because in the numerator side, we have 4 factorial, but again, in the denominator side, we have 4 factorial. So you can simplify very easily like this. So here we are going to remain with 5 times. Now remember, in the bracket we have 7 times 6. 7 times 6, this is 42 minus 1. Over, for the denominator, we have 6 times 5 minus 1. But 6 times 5, this is 30 minus 1. So, my dear student, we are going to have 5 times. Now, inside the bracket, we have 42 minus 1, which is going to be, that is 41. Over, for the denominator side, we have 30 minus 1, which is equal to 29. Now again, my dear student, you can use your scientific calculator to find the final answer. So just take your scientific calculator and plug in the data remain. That is 5 times 41 divided by 29. Now, the final answer is equal to 7.068965517. I think even you have the same answer as you have seen here. We have seen how to use the factorial notation, and you have seen the general formula of factorial notation. Now, let us see the application of factorial notation. And one of the areas where we apply the factorial notation is permutation. Permutation, of course, and the combination. But these two words, permutation and combination, confuse some of the students. Now, to clear the doubt, I will differentiate between permutation and combination as follows. My dear student, by definition, permutation refers to arrangement of other things out of anything when order is important. That means when we are talking about permutation, the order is very important. And it is general formula. It is NPR is given by n factorial over n minus r factorial. Remember, we've already discussed about factorial notation. So when I write factorial, I think most of you are familiar with factorial. When we go for the second case, that is combination, by definition, combination refers to the selection or choosing of items when the order is not important. So the issue to care here is that combination is selection or choosing of an item whereby order is not important. Now you can see the differences between permutation and combination. In permutation, the order is very important, but for combination, the order is not important. Now, my dear student, consider three pieces of marble. Labeled A, B, and C. We're having three pieces of marble which are labeled A, B, and C. For the case of permutation, if we want to choose only two pieces of marble out of three, we could say 3P of 2. Why? Because we are having three marbles and we want to choose only two. So by using our general formula, we could say this is the same as 3 factorial over 3 minus 2 factorial. What are we going to get here? This is equal to 3 factorial over 3 minus 2 remain with 1 factorial. So 3p2 will be equals to, now remember this, the expansion for 3 factorial by recalling the general formula for factorial notation is the same as 3 times 2 times 1 over, now remember 1 factorial is equal to 1. So here we just write it over 1. So 3p2 will be equals to 3 times 2 times 1, which is equal to 6. Now again, this is permutation. Now suppose the same case, 3 pieces of marble, we need to choose 2, where the order is not important. We could say this is 3c2. I think remember the formula. That is 3 factorial over 3 minus 2 factorial 2 factorial. That is for the case of combination. Now, what are we going to get here? Remember the concept of factorial notation. That is 3 times 2 times 1 over. Now again, the number which are inside the bracket has no factorial notation. So you just take 3 minus 2. You are going to remain with the 1 factorial times 2 factorial. Now, that is 6 over, remember I said 1 factorial is equal to 1. And the 2 factorial is the same as 2 times 1. So the last answer you can simplify here by saying by 2 is 1, by 2 is 3. We are going to end up with 3. Now, my dear student, you can see the differences between permutation, where we choose 2 items out of 3 with order important, and case 2, that is combination. We have 3 mabels, but we decided to choose only 2, but order is not important. We end up with 3. What does this mean? In arrangement, we can do as follows. Remember, case 1, this is permutation. That is permutation. And case 2, this is combination. Let me show you. Then we will differentiate between permutation and the combination. We said in permutation, the order is very important. You arrange 3 pieces of mabel in order. But of course, remember, we choose only 2 mabels out of 3. So we could say you can choose A, B, that is 1. But again, the second case can be B, A, because the order is important. AB is not equal to BA. But again, you can say A, C, C, A, because AC is not equal to CA, because in permutation, the order is very important. And the last case, it can be A, C, sorry, that is B, C, and C, B, because BC is not equal to CB. Now, try to count these items we have. We have 1, 2, 3, 4, 5, and 6, which is the same as the answer we got here. But for the case of combination, remember, order is not important. For the case of combination, order is not important. So, A, B is the same as B, A. You can group like this. That is AB is the same as BA. Why? Because the order is not important. And again, AC is the same as CA. Why? Because the order is not important in combination. And the last one is BC and CB. So now try to count what we have. We have 1, 2, 3. So we end up 3 items, which is the same as 3 we got by using the general formula. My dear student, remember what is important in combination and permutation. For combination, the order is very important. But for combination, the order is not important. That is what differentiates between permutation and the combinations. I think we are together up to this moment. Now, my dear student, let us see some questions. And I'm sure you are going to join with me and tell me that the question, is it fall in permutation perspectives or combination perspectives? The first question, my dear student. How many ways can you arrange 5 books on a shelf? How many ways can you arrange 5 books on a shelf? Now, by using the 2 definitions of permutation and combination. Remember, in permutation, the order is very important. And for combination, the order is not important. Now, in this question, which perspective suits our question? Is it permutation or is it a combination? Try to think. My dear student, I'm sure that you will join with me that in this question falls in the first perspective, that is permutation. Because when you arrange books in a shelf, there is a certain order to follow. Therefore, for our case, how many ways can you arrange 5 books on a shelf? It will be the same as 5p of 5, because there should be an order. Now, by using our general formula for permutation, this is the same as 5 factorial over 5 minus 5 factorial. Remember, the general formula for permutation is equal to n factorial divided by n minus r factorial. That is our general formula. That is why we just plug in 5 factorial over 5 minus 5 factorial, which is the same as, remember the expansion for 5 factorial, our first definition of factorial notation. This is equal to 5 times 4 times 3 times 2 times 1 over, then we have 5 minus 5. This is equal to 0 factorial. Now, for the part of numerator, you can use your scientific calculator to get the answer. I'm sure most of you who are taking basic applied mathematics, you have the scientific calculator. That is now for the case of numerator, we have the answer, that is 120. For the case of denominator, we have 0 factorial. In mathematics, 0 factorial is equal to 1. So even by using a calculator, you can prove that is 0 factorial is equal to 1. So here we have 120 divided by 1. Therefore, the final answer will be 120. My dear friend, this topic is very simple. If you practice, you will be perfect. Now, my dear student, let us continue with another example. Okay, that is question number 3. That is question number 3. We have question number 3. The question says, how many committees of 4 people can be selected from a group of 10 people? That is your question we have. Now again, remember we've defined permutation and combination. You know their definition and you know how they differ. Remember, I remind you, in permutation the order is very important, but for combination the order is not important. Now look to our question. If the question order is important or not important, try to think where you are. Try to read the question again and see whether the question falls in permutation perspectives or combination perspectives. My dear student, selection of a committee, the order is not important. This question falls in combination. Therefore, we could say remember we have a total of 10 people, that is n is equal to 10, and we need only to choose 4. Therefore, R here is equal to 4. Now, by using our general formula, we say that is n CR is equal to n factorial over n minus r factorial, then r factorial. That is the general formula for combination. Now let us substitute what we have. So we have 10C4 is equal to the value of n, that is equal to 10 factorial over, then again we have n minus r, that is 10 minus 4 factorial, then again times r factorial, which is equal to 4 factorial. For this case, you can use your scientific calculator to find the final answer, or you can proceed like this. Remember the expansion for 10 factorial by using the definition of factorial. That is, we have 10 factorial, that is 10 times 9 times, we have 8 times 7 times 6 factorial. Why 6 factorial? Because we have seen 10 minus 4, that is 6 factorial times 4 factorial. In this case, you can simplify 6 factorial and 6 factorial. That is why I end up in 6 factorial. Otherwise, if in the denominator side there were no 6 factorial, I could proceed until 1. So you can simplify this way. 6 factorial and 6 factorial can disappear that way. So we are going to remain with numbers without factorial in the numerator side. That is 10 times 9 times 8 times 7 over, for the denominator side we have 4 factorial, which is the same as 4 times 3 times 2 times 1. Now, my dear student, again, we are in the position to use your scientific calculator to get the final answer. Now, take your scientific calculator and proceed with me. My dear student, I hope that you are going to end up the same answer as what I got here. That is 210. So 210, that is your final answer. Oh, my dear student, now it is time to hear from you. We have seen the differences between permutation and combination. But again, the knowledge of factorial notation. Now, I'm in the position to hear from you. This part of presentation, we have revised the questions concerning to factorial notation, that is factorial notation, and the second subtopic was permutation, and the third one was combination. For the case of permutation and combination, we have seen the differences between them. For the case of permutation, just to remind you, is arranging items with the care of order. But again, for the case of combination,
Mtazamaji wa TBC1, kumradhi kwa kukatisha kipindi ambacho kilikuwa kikiendelea. Tumerejea tena kuelekea huko mkoani Iringa ambako matangazo ya moja kwa moja katika kuuaga pamoja na mazishi ya waziri wa sheria pamoja na katiba na ambaye pia alishawahi kuwa waziri wa mambo ya nje na ushirikiano wa Afrika Mashariki, Dr. Balozi Augustine Mahiga. Mwenzetu huko ni Shaban Kisu. Shaban, kama unanisikia, nafasi ni kwako.
Mtazamaji, hii ni TBC ikitangaza moja kwa moja kutoka hapa mkoani Iringa, na hapa tuko katika eneo la Tosa Maganga, na hili ni kanisa la Moyo Mtakatifu wa Yesu, na hapa ndipo ambapo ibada kwa ajili ya mpendwa wetu alikuwa waziri wa katiba na sheria Balozi Dr. Augustine Mahiga itafanyika, na kama unavyoona maandalizi yote muhimu yameshafanyika, na hivi ninavyozungumza mtazamaji, mwili umeshawasili hapa katika eneo hili la kanisa. Taratibu zinamalizwa pale nje. Namuona waziri wa ardhi, nyumba na maendeleo ya makazi Mheshimiwa Lukuvi, lakini mkuu wa mkoa, mkuu wa wilaya mwenyeji wetu Mheshimiwa Kasesela, katibu mkuu wa Wizara ya Katiba na Sheria Profesa Mchome, pamoja na viongozi wa kimila wako kule, na hapa sasa ni taratibu tu zinafanyika kwa ajili ya kuingiza mwili kwenye kanisa hili la Moyo